Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Ahmad Azri bin Syed Mohamad, number metric 1192524. Today I want to discuss about econometric modeling Malaysia road accident. Accident usually caused by a combination of five factors, which is behavior of driver, infrastructure of road quality, traffic volume, and the environment. The increase of these accidents are seldom been correlated with factors such as driving behaviors, traffic condition, vehicle condition, and others. Nevertheless, it cannot be denied that the macroeconomic factors also contribute in explaining the occurrence of road accident deaths. The illustrated of graph shows that how many road crash between year 1974 to 2019. The pattern is increasing from time to time. Graph 4 shows the relationship between road crash and road length. Road length RL is road length. The data displayed there are plot did not correlate each other much, and pattern is like snake pattern. The linear get touched with for plot of road crash. Graph 5 shows that relationship between the road crash and gross domestic product, or known as GDP. The data illustrate that the plot near with linear and group at two places. First at GDP 4.5 and second the end of the linear. Descriptive statistic. But can we learn by comparing the mean and median for both variables? For the road crash data, they are virtually equal 5.21 and 5.24 respectively. For symmetric distribution, the mean and median will be very close together. That's a good sign that the road crash follow a symmetric distribution, making the mean good choice. The mean tells us that our road crash distribution center of on 5.22. There is the RV mean 6.88 and the median 6.91. The POP mean 7.30 and median 7.33. The RL mean 4.77 and median 4.88. The GDP mean 4.9 and median 4.96. However, when the mean is greater than the median, it indicates that the distribution is right skew. Standard deviation, the standard or typical difference between each data point and the mean. This measure use the original unit of the data simply interpretation. The variance, the average square difference of the values from the mean. Because the circulation use the square difference, the variance is the square unit rather than the original data unit, while higher values of the variance indicate greater variability. There is no intuitive interpretation for specific values. Range, the difference between the largest and smallest value in the data set. The range is easy to understand but is based on only the two most extreme values in the data set, making it very susceptible to outliers. Additionally, the size of the dataset affects the range. As the sample size increases, the range tends to expand. Consequently, use the range to compare variability only when the sample sizes are similar. Typically, use the standard variation when have fairly skewed data. Consider using the interquartile range IQR. For the road crash data, the standard deviation is 0.38. The typical height falls 3.86 from the mean of 5.22. The range tells us that the spread from the height to the low is 1.36. For the RV data, the standard deviation is 0.42. The typical height falls 6.46 from the mean of 6.88. The range tells us that the spread from the height to the low is 1.46. For the POP data, the standard deviation is 0.16. The typical height falls 7.14 from the mean of 7.30. The range tells us that the spread from the height to the low is 0.49. For the RL data, the standard deviation is 0.336. The typical height falls 4.41 from the mean of 4.77. The range tells us that the spread from the height to the low is 1.26. For the GDP data, the standard deviation is 0.47. The typical height falls 4.43 from the mean of 4.9. The range tells us that the spread from the height to the low is 1.6. Kurtosis and skewness are two measures that help you understand the general properties of your data distribution. This measure compare your distribution shape to a symmetric distribution and the normal distribution. When either kurtosis or skewness significantly deviate from 0, it might indicate that your data data do not follow a normal distribution. However, use a anomaly test or normal distribution plot to make the determination. For the kurtosis, for example, kurtosis indicate how the peak and the tails of your distribution compared to the normal distribution. Is the peak taller or shorter than the normal distribution? The tails thicker or thinner? For my example data, RC has kurtosis of negative 1.27. This value is close to 0, indicating that the tails are consistent with the normal distribution. However, RV has kurtosis of negative 1.03, suggesting the tails are thinner than population. Between all these five GDP is more consistent. Between all these five variables, GDP is more consistent with normal distribution. Skewness for skewness indicate that symmetry of your data distribution. Skewed data are asymmetric. The terms right skewed and left skewed indicate the direction in which the long tail point on distribution curve. For example, data broadcast has a skewness of negative 0.1. This value is close to 0, signifying that this data has a symmetric distribution. However, RV has a skewness negative 0.24, which indicates it's left skewed. The relative location of the mean and median and this distribution properties paint a consistent picture of these two variables. For the RC data, the mean and median are nearly equally, and kurtosis and skewness are both virtually 0. These measures collectively imply that the height follow a symmetry distribution consistent with the normal distribution. Conversely, the RV data have a mean that is higher than the median, a positive skew value, and the possible and positive kurtosis value. This value suggests that the variables follow a symmetric skewed distribution that is not consistent with the normal distribution. Okay, minimum and maximum. The minimum and maximum values in your data in my data set can help where your data fall. For example, data the RC road crash fall between 3.49 and to 5.74, while the RV fall between 6.04 to 7.5. Additionally, these values can help identify outliers. Frequently, the data entry errors create values that fall outside the range of valid data. Sum and count. The sum is simply the sum of all values for each variable. Use this value to determine whether the sample size is what you expect. What is my expect? All the RC, RV, population, RL, and GDP variables have 46 observations. Standard error and of the mean. The standard error of the mean is the standard deviation of the sampling distribution of the mean. If I took many samples from the same population and calculated each sample's mean, I produce a distribution of sample means. That distribution has a standard deviation, which is the standard error of the mean. Smaller standard error indicate that my sample provide a more precise estimate of the population value. Regression analysis. Multiple R. This is the correlation coefficient. It tells how strong the linear relationship For example, a value of 1 means a perfect positive relationship, and a value of 0 means no relation at all. Is in the square root of r squared. R squared, the coefficient of determination. It tells how many points of fall of the regression line. For example, 97% means that 97% of the variation of dependent variables around the mean are explained by the independent variables. In other words, 97% of the values fit the model. Adjust r squared, adjust for the number of terms in a model. Standard error of the regression for an estimate of the standard deviation of the error. This is not the same the standard error in descriptive statistics. The standard error of the regression is the precise that the regression coefficient. It is measured if the coefficient is large compared to the standard error. Then the coefficient is probably different from 0. Observations. Number of the observation in the sample, which is 46. The second part of output ANOVA is rarely used compared to regression output above. It splits the sum of square into the individual component, so it can be harder to use the statistic in any meaningful way. Significant F value that gives an idea on statistically significant for my result, which are significant F is less than 0.05. That's 5%. Our model is okay, or good model. We will look at basically at my intercept. If all independent variables is 0, the change root crash will give negative 0.64. It is not logic, because if all independent variable is 0, it should be 0 also, because nothing happened. For RV, if the registered vehicle increased by 1%, then the road crash is predicted to change by 118%. If the population increased by 1%, then the road crash is predicted to change by negative 11%. If the road length increased by 1%, then road crash is predicted to change by negative 33%. It will less road accident. If the GDP increased by 1%, then road accident is predicted to change by 2%. Okay, for the t-stat is related to p-value. So I test one by one my variable. So I set my alpha equal to 0.1, 0.05 and 0.01 interval. If this 4 variable is less than all the interval is a good coefficient and can reject null hypothesis. RV is success to reject null hypothesis with all interval. Population can reject null hypothesis on 90% interval but fail to reject on 95% and 99%. Road length succeed to reject null hypothesis with all interval. However, GDP was failed to reject any of interval, which is 90%, 95% and 99%. For the conclusion, recent development in the econometric analysis of the time series is used to estimate the road accident. But this econometric approach is somehow only suitable for the purpose of developing a model and identifying the factors that significantly contribute to the model. One of the disadvantages of using this approach is that it may not truly represent the actual pattern when doing forecasting for the future values due to the stationarity characteristic of the data series. Time series observations are typically serially correlated. Thus, it is recommended that the modeler should consider the error correction mechanism approach for the future research. Thank you for listening my presentation. Assalamualaikum warahmatullahi wabarakatuh.